All right, I've been asked about when to use discriminants, and once you are using discriminants, which discriminants should you use? So, first of all, when to use a discriminant. This is a really straightforward thing, really. We only use discriminants, or that's not quite true, we mostly use discriminants where we've got non-numeric coefficients of our x values if we're, say, using a quadratic, for example. So let's say, for example, you've got um, well, let's choose a really easy example. Now, so I've got x squared plus something x plus 4. So here's my quadratic, and let's say it equals 0. And I'm wanting to say, well, we've got this coefficient of x. So we've got a coefficient of x to the 1, x to 2. This is going to be a 1. That's the coefficient is a 1. The coefficient of x to the 1, though, is a k, and the coefficient of x to the 0 is a 4. But we don't know what the k is. So we'd use the discriminant to reconcile the situation where we have a non-numeric coefficient of an x value. So in this case, let's go ahead. And if we were to go ahead and do that, we would say, okay, what are the coefficients here? Well, the coefficients in this case, the coefficient of x squared is a 1. So a becomes 1. The coefficient of x to the 1 is b. And b, of course, is k. The coefficient of x to the 0 is 4. So c is 4. Then we go ahead and we use the discriminant, which is b squared minus 4ac, and that is going to be 0. We make it equal to 0. Now, of course, which discriminants to use? Now, you're making it equal to 0 because we want to find the critical values. So whenever you want to find the critical values of, in this case, an unknown coefficient of x, we always make it equal to 0. Okay, and you're going to see in a moment making it less than 0 or more than 0, or making it equal or less than 0, or making it greater or equal to 0. But in this case, we make it equal to 0. All right, let's find the critical values of k. In other words, what are the possibilities for k? What could it be? Well, let's take a look. And the critical values, by the way, are single values. They're individual values. They're not ranges of values. So let's have a look. So let's populate the equation with the metrics we have. So b squared, well, b is k, so it's going to be k squared minus 4 times, well, a is 1 times c, well, c is 4, and that's equal to 0. So k squared minus, in this case, 16 is equal to 0. So let's go ahead and find out the value of k. So I'm going to add 16 to both sides. 16 minus 16, of course, is 0, and I'm left with k squared is equal to 16. Now, if I want to find k, all I need to do is say, let's take the square root of k, square root of 16. So I'm finding the square root of both sides. And when I do that, I must make this plus or minus. And the reason I must make it plus or minus is very simple. If I've got a value of, let's say, let's call it k squared. K squared. Let's say k squared is 16. Well, what could k be? K could be one of two things. It could be negative 2 squared. That would be negative 4 squared. I'll just make that a little bit nicer. Here we go. No, good. Could be negative 4 squared. There it is. And that would be 16. Or it could just be 4 squared. That would also be 16. So it could be a plus 4, or it could be a minus 4. But what is the square root of 16? Well, the square root of 16 is only 4. Is only 4. And because we know it could be plus 4 or minus 4, we have to put the plus or minus in front of it, showing the two options are going to be potential answers. Could be plus 4, could be minus 4, but we know k has to be either of those two. All right, so what have we found? We found values for which makes this true. And of course, x squared plus k, x plus 4. Let's have a look at that. So I've got k squared, not good. Okay, I've got an x squared x squared plus, well, let's say k 4. 4x plus 4 equals 0. What have we got? Oh, we can factorize that quite nicely into x, and then x, signs are the same, biggest, both positive, and we've got a 2, and we've got a 2. And we've got a nice perfect square there. Of course, it could also be minus 4, and that would also work. Because really all we're doing is we're saying, what are the possible values of k that would make this equation true? Well, you could have an x plus 2 and x plus 2, or you could have, let's go x squared minus 4x. So this becomes a minus 4 plus 4. Remember, this was our k value. This was our k value, yeah? And of course, in this case, it's going to be an x and an x. Signs are the same, both are negative, and I've got a 2 and a negative 2, a negative 2 and a negative 2. And again, that now makes that true. So you could have a range of things, but the k determines what are the potential range of things that makes this equation true for the values of k. And that's the purpose of when to use a discriminant.